Good day everyone. Today we will discuss what and how to solve a linear programming problem step by step that shows real life application. So now I'll show you an example for you to better understand how to solve a linear programming problem. So here's our example. A digital marketing manager for a new e-commerce product is planning an advertising campaign using two channels: video ads on streaming platforms and display ads on websites. The goal is to maximize the total expected numbers of purchases where video ads yields 4 expected purchases per 1,000 ads and display ads yields 3 expected purchases per 1,000 ads. The total budget for the campaign is 8,000. Video ads cost 100 per 1,000 and display ads cost 50 per 1,000. Furthermore, the campaign requires that the manager must purchase at least 10,000 video ads and at least 20,000 display ads, but cannot exceed an inventory limit of 16,000 video ads or 120 display ads. The manager needs to determine the optimal number of thousands of video ads and display ads to purchase.
So let us define the variables. So let X be the number of video ads to purchase in thousands and Y be the number of display ads to purchase in thousands. So now, to define our objective function, let me call on Miss Parian.
So let's begin about the objective functions. The goal is to maximize the total expected purchases based on the response rates. In this part, we need to find what is the problem in the statement. The problem is that the manager needs to determine the optimal number of thousands of video ads and display ads to purchase. Maximize Z equals 4x plus 3y. Now, what is Z? Z is the number of the purchases of video ads and display ads. 4x or 4 times x comes from where the video ads yield 4 expected purchases per 1,000 ads, and the 3y comes from display ads yield 3 expected purchases per 1,000 ads. The constraints will also discuss or continue by Ms. Nera.
So let's break down the constraints in the context of the digital marketing campaign problem. So the total spend on the video ads and display ads cannot be exceed to $8,000. So the mathematical representations that we have here is the 100x plus 50y is less than or equal to 8,000. So the X represent the thousand of video ads and the Y is the thousands of display ads, and the 100 is the cost per thousand per video and the 100 is the cost per thousand video ads and the 50 is the cost per thousand display ads. So the simplified form, we have the 2x plus y is less than or equal to 160. You can simplify it by dividing the original inequality by 50. So the video ads minimum, the manager must purchase at least 10,000 video ads. So we have here the mathematical representation, which is the x is greater than or equal to 10. So the display ads minimum, the manager must purchase at least 20,000 display ads. So here you can see the mathematical representation, which is the y is greater than or equal to 20. So the video ads maximum is the campaign cannot be or the campaign cannot exceed an inventory limit of 60,000 video ads. So here the mathematical expressions is the x is less than or equal to 60. So for the display ads maximum is the campaign cannot exceed an inventory limit of 120,000 display ads. So we have the mathematical expression here, a representation instead, perhaps. Mathematical representation. Y is less than or equal to 120. So for non-negativity, the number of video ads and display ads cannot be negative. So that's why we have that. So for the given to be not get negative. So we have the the mathematical representation here. The x is greater than or equal to 0, or the y is greater than or equal to 0. So these constraints define the feasible region within the which the digital marketing must operate to determine the optimal number of video and display ads to purchase. So yeah, while staying within the budget and meeting the minimum or the maximum purchases requirements. So yeah, so later you'll see the visual, or you'll see a graph that you can use to furthermore understand how this works, or how you um more visual, or how you more understand about this problem. So yeah, that's all. Thank you.
So first step in graphing the linear programming problem is to write the minimum capacity and the maximum capacity. So we have x is greater than, this is a minimum, greater than or less than or equal to 10, while y is greater than or equal to 20, and the maximum capacity is the y is less than or equal to 120, while the x is less than or equal to 60, where x should be it should be included the non-negativity. So it should be x is greater than or equal to 0, while y is greater than y is greater than or equal to 0, and let's hide the color so that zoom out lang natin para makita yung ibang region. So ayan, we're having clear view. So yan, and then we will input the our objective function, which is the z is equals to 4x plus 3y. 4x z, so let's introduce another 4x plus 3y. So should have a slider. Ayan. Next is the budget constraint. So yan. So the total cost must not exceed the 8,000 budget. So let's simplify the budget constraint to a smaller value. So magiging 2x plus y, because divide natin siya sa 50, y is less than or equal to 160. Ayan. na. So, makikita na natin dyan ang kung saan sila yan yung mga points. So, 0, 160, 10, 140, 20, 120, 60, 40, 80, 0, 720. So, ayan. So, sa 10, 120. And then, makikita natin yung mga optimal points na so, the feasible region is this triangle because dito sila intersect lahat. Yan. So, let's move forward to the interpretation. So, the linear programming problem was solved to maximize the total expected number of purchases based on advertising budget of 8,000. So, the optimal solution found was 20 and 120 with a maximum C value of 440. So, optimal allocation. So, the manager should allocate the advertising budget to purchase 20,000 video ads and 120,000 display ads. So, the maximum response is to generate a maximum of 440 total purchases, which is the highest response possible under the given constraints. So, sa budget utilization, so the solution requires spending the entire 8,000 budget. So, to solve, video ad costs 20,000 ads per ads times 20,000 ads rather times 100 per 1,000 ads is equals to 2,000, while the display ad cost is equal to 120,000 ads times 50 per 1,000 ads is equals to 6,000, with a total cost of 8,000. 2,000 plus 6,000 is equals to 8,000. So the conclusion is the budget constraint is used up completely, meaning the budget is the primary limiting factor in achieving a higher response. So higher budget, mas higher allocation pa or mas higher ads pa yung kayang ma-purchase. So that's all, and thank you for listening, and I hope you gained a knowledge about linear programming.